Hi friends, welcome to the world of Neural Pruning. Myself is Shiva Kumar. I am the lecturer in chemistry. I finished my masters in 2001 from Bangalore University. I have an experience of 19 years which is very much helpful for the students who are in need. My strength is I convert the difficult understanding topics to a much more easier level where the student can understand better and the outcome in the examination is maximum. To my credit, I have written the book under JEE publication under the guidance of Dr. Iragowda, who is my guru, Professor Sridhar Murthy sir. I am very much thankful for their guidance to reach at this level. Dear students, do not be late to subscribe these videos under Neural Pruning, which is going to get you a success in different level of competitive level exams as well as board level exams. Students, now we have seen which are the subtopics which are coming in this particular chapter. Under that, the first subunit point which we are coming across is reaction rate. To understand this reaction rate, you should know few basic terms. I do know that the students who are listening, they have the knowledge of basic terms. But here, if you are not aware about the basic terms, the understanding of these terms which I am going to use in my sentences, it is going to be difficult for you. So we are all studying from our younger age about the chemical reactions. When we are observing a chemical reaction, usually we use two terms, that is reactants and products. When we are coming across the reactants, generally we are going to write the chemical reactions with left hand side as reactants, as I have shown here on the board as R for reactants. So reactants will undergo reaction to form products. So this is the basic term which you have to remember. So R for what, children? Reactants. P for what? Products. Now let us consider with an experimental manner how does the reaction proceed. If I just consider here if the diagrammatic representation of the reactants which is having more concentration at what time? T1. So what will be the concentration of the reactant we are considering at T1 is R1. We are considering it as what? R1 at time T1. During the course of the reaction, we are going to observe that if you see in the second diagram, after a time interval T2, we are going to observe that the reactant concentration decreased and gradually the concentration of products increased. So whenever we are coming to reaction rate, it is being given as change in concentration for a given unit time. But if I go to the other part, in our daily life, we'll be coming across rate with related to three terms. The rate we are going to use for price tag. How much is it? 100 rupees. The same RATE only we are using. Don't get confused with chemistry rate. Then one more tag which you are going to come across is rate. Usually with related to objects you are going to come across. That is movement of a vehicle, movement of an object. We are going to calculate speed. Speed is being given as distance traveled by given interval of time or unit time is being given as what? Rate. It is usually for vehicles we are going to calculate with related to a kilometer per hour per minute per second, it goes on. Whereas when it comes to chemistry, we are giving the rate with related to two factors, either with related to decrease in the concentration of reactants. Can you observe this diagrammatically which I have shown? Then either with related to increase in the concentration of products for a given interval of time. So if I write it with the expression, we are going to give this as rate is equals to minus delta R by delta T. We are going to have the numericals related to these formulas. Now, when we are focusing how did we arrive at this formula, it is being obtained with related to when we are calculating it for reactants. The other words what we are going to use for the reactants is the disappearance. I've already told you in the beginning of the talk that you have to remember few words. When we observe this reaction, we are going to use this word as disappearance of reactants, appearance of products. So here the rate is being given as minus of R2 minus R1 by T2 minus T1. Here the reactant concentration is less at T2, reactant concentration at T1 is greater, so the value is what you are going to get is negative. So the difference of these two reactants, we are going to write it as delta R by delta T. Delta is representing in the rate expression as for a large interval of time. Delta represents for what? Large interval of time. So this is the expressions which we have done with related to reactants. Similarly, we can do it for the products. Now, when we consider with related to products, I've already told you that we have to use the word appearance. Appearance of the product at a given time. We can calculate the rate with related to both reactants as well as the products. Now how it will be given for the product is rate is equals to P2 minus P1. So here when we consider the diagrammatically, we have seen that in P1 there are no reactants are being formed at 0 time or T1. Here we are considering it as a low value, this is a higher value divided by T2 minus T1. If I proceed further, you can write this expression as delta P by delta T. Here we are getting positive. Here we are getting rate as negative. The question comes for the student is, how can be the rate be positive and negative? Please remember that whether it is a rate with related to object or with related to the chemical reaction, it is always positive. So here in chemistry we are multiplying with -1. If I multiply with -1, it is going to be positive. So the rate can be expressed with related to two aspects. Now this can be given as the rate average. See, now I am going to introduce average. Average. Here also you can use the word average. 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 That is, rate average is the measurement of the rate of the reaction for an large interval of time, which can be studied further with a graphical representation.